Okay, good morning everyone. Today discuss about the vector chapter because why we are learning this chapter. That's very important chapter also because why we are learning. First of all, if you want to measure the distance, either x-axis or y-axis, we can find out easy. For example, we can write the x-axis direction. The x-axis direction always we can measure or 1 meter, 2 meters, 3 meter, whatever it may be. It can be measured easy on x-axis. Y-axis we can be measured. It is easy to understand the where we can moving from origin point. As origin means it is a starting point. We can measure easy. Okay. If we want to the body moving other than x-axis and y-axis, then we shouldn't find out the distance of the other than x-axis and y-axis. Then what need to do? We can use the vectors. Means if the particle or body is moving other than x-axis and y-axis, then we can apply the vectors. Okay, we are using the vector chapter. These vector chapters always we can use in every chapter. Okay, that's why this chapter is very very important. Okay, first of all, what is the physical quantity? We need to learn the what is the physical quantity. This physical quantity means what? A quantity which can be measured. A quantity which can be measured. What type of quantity is there? We can measure easily. For example, length. Length we can measure. That is a physical quantity. Mass in terms of kilograms we can measure. That is called as a physical quantity. But air is there. Air we can't measure. That's not a physical quantity. Are you able to understand? That's why physical quantity means what? A quantity which can be measured. A quantity which can be measured. Which can be measured is called as a physical quantity. These physical quantity are classified two types. The first one is scalar quantity. First one is scalar quantity and second one is the vector quantity. Second one is the vector quantity. Okay, what is the scalar? Scalar means a quantity which having only magnitude. Which having only magnitude. Which means, for example, we want to take the mass of the body. Okay, mass. Mass means we know the definition very well. I think the amount of particle combined in a body, that is called as a mass. This mass we can measure in terms of kilograms. This mass having doesn't have any directions. Yes, for example, 20 kilograms of the body is there. That is the mass. This mass of the body doesn't have any directions. It doesn't move. Okay, it's not a specified direction. Only it is having a only magnitude. Magnitude means this is the magnitude. The number, the numerical value indicating the magnitude. This is called as a magnitude. Okay, this magnitude. This is the unit. Yes, this is called as only magnitude will be there in the quantity, that is called as a scalar quantity. For example, distance also we need to consider. Distance means the body will be moving from one place to another place. Whatever the paths will be there, but the body will be moving in a different ways. For example, from A to B path is there. The distance is moving like this, or the distance is moving in this way, in different way. It's not a specific direction. Yes or no? It's having only magnitude. It's having only magnitude, that is called as a scalar quantity. Okay, the next one is vector quantity. That's a very important chapter. That is called as our chapter vector. Okay, the vector means what? Both magnitude and direction is called as a vector. But generally, in before cases, you are studying the only scalar and vector. Vector we can say simply if the body having a both magnitude and direction is called as a vector in the previous classes. Yes. But actually, in this chapter learning, not only the both magnitude and direction, but also obeys the laws of vector addition. If the obeys the laws of vector addition, then the body is said to be a vector quantity. Otherwise, it is a scalar quantity. For example, we want to take the electric current. Electric current. Okay, this electric current, for example, the current will be in a dividing the different paths. That is the total current I1 and I2. A total current we can write the in terms of equation I is equal to I1 plus I2. Okay, the amount of current, the magnitude is there. In the same way, if you want to take the another path like this, the current I1 current, I2 current. What is the meaning? It can be changes the angle. Here only theta is there. Here only 90. Exactly. Yes or no? The angle changes, but total amount of current is same. Yes. But laws of vector addition explain whenever the angle can be changes, the magnitude must be changes. Means total quantity can be changes. That's a called as a laws of vector addition. This concept you can learn in the next videos. Don't worry about it. That's a called as a best example of electric current, but it's having a direction, but it does not obey the laws of vector addition. That's why we call it as a current. Electric current is a scalar quantity. Already I told you that if it does not obey the laws of vector addition, then the body is said to be scalar quantity. When it is the vector quantity, if the body having a not only the magnitude and direction, but also laws of vector addition, it should be obeys. When it is the obeys the laws of vector addition, then the called as a vector quantity. Otherwise, scalar quantity. This is the best example of scalar quantity. See, and next one. And next one, we need to learn the representation of vector. But how the representation the vector? See, representation of the vector. Representation of the representation of vector. How to representation the vector? See, for example, if the force is there or any vector is there, that is the force. Force is a vector quantity. Yes, that's why we can write the bar. Bar means it shows the direction, or we can write the in other way. It's place the some arrow. Arrow also it can be shows the direction. It is also indicating by the vector quantity. And one more thing is there. We can represent the bold letter of the quantity. For example, we can write the bold letter. Okay, that's a dog and bold also. That's a called as a representation of vector will be there. When you shown like this is called as a vector representation. Okay, because force is having a magnitude and direction also it can be shows the bar. That's a called as a representation of vector. From these, sometimes we can shows the magnitude. How can you shows the magnitude? For example, one arrow will be there. Yes or no? It's a very important. The length of the arrow from here to here will be there. For example, the length of the arrow indicates the magnitude of the quantity. Magnitude of the quantity. For example, this is the 5 newtons is there. Okay, 5 is the magnitude. The length can be indicating by the magnitude. So, direction indicating by the arrow. Direction indicating by the arrow. That's why we can understand the magnitude and the direction. That's why we call it as a vector quantity. From this, the magnitude, the length can be indicating by the this number. Number is nothing but a magnitude, multitude, and whatever the names we can call it as. That's based on this arrow can be represented as the vector quantity. This is the representation of the vector quantity. And next concept is that's a very important types of vectors. The next one is types of vectors. Types of vector. Types of vectors. There are different types of vectors are there. What are the different types of vector? First of all, we need to write first one. The first one is equal vector. The first one is equal vector, and second one is parallel vector, parallel, or other name is like vectors. Parallel means or like vectors. We call it as different. Next one, anti-parallel vector. Anti-parallel vector means overall unlike vectors. Unlike vectors. And fourth one is a negative vector. Fourth one is negative vector. Next, fifth one is null vector. Fifth one is null vector. Sixth one is co-initial vector. Co-initial vector. And seventh one is co-planar vector. Co-planar vector. Next one is co-axial vector. Means we call it as a axial vector. Simply we can say axial vector. And next one polar vector. Last one is unit vector. This is a very important topic we need to learn. These are the different types of vectors. First of all, one by one we can learn it. Okay, what is the meaning of, and with examples also we'll discuss. Okay, the first one is we'll discuss now. The first one is equal vector. The first one, equal vector. Equal vector means the condition is very important. If the quantity must be same physical quantities and same magnitude. Same physical quantity and same magnitude. Same physical quantity. Same physical quantity and same magnitude. Same physical quantity and same magnitude. Same magnitude. Okay. What is that meaning? Same physical quantity and same magnitude. Okay, now discuss. For example, we want to take the one arrow. This is called as a, for example, force. Force is 10 newtons is there. Okay. Another vector must be, it's called as a same physical quantity. Same physical quantity means if you want to take the force, here only force. If you want to take the force, if you want to take the 10 meters, it is the displacement. Displacement means it's not a physical quantity. It's a wrong. Then what need to do here? It must be takes the 10 Newton force. Okay. Or we can write like this. Or the vector 10 newtons is there. We can write. Or 10 newtons we can write this. Okay. Whatever the direction will be there. It's the same physical quantity and same magnitude. Will be 10 Newton. 10 Newton. Newton is a units of force. It's the same physical quantity. And same magnitude, same number will be there. That's by the equal vector. What is the equal vector? A vector which having same physical quantity and same magnitude. That's called as a equal vector. This is the equal vector. And next one, parallel vector. Next one, parallel vector. Parallel vector or like vectors. Parallel vector means it's having same physical quantity. It's a maybe or may not be magnitude is same or different. It's a not particularly, not always. It may be or may not be. Okay, see for example, if you taken as a 10 newtons force, for example. Another one is we need to take the 5 newtons is there. But those vectors must be in a parallel. Those vectors must be in a parallel. But it must be same physical quantity. Means units is nothing but units of force. That's Newton is the units of force. That's the same physical quantity. But the magnitude is maybe or may not be equal or different. Okay, it's not must be equal, maybe or may not be. That's a called as a parallel vector. If you want to write here, those vectors must be parallel with each other. What is the angle between them? That is the theta must be 0 degrees. When the two rays are in parallel with each other, the angle between the two parallel lines is called, what is the angle? 0 degrees. That's called as a parallel vector. But it must be same physical quantity. Okay. Next one, anti-parallel vector. The next one is anti-parallel vector or unlike vectors. Anti-parallel means it is opposite way. For example, same physical quantity, but in those are anti-parallel. For example, if you want to take the quantity here, 20 newtons is there. Okay, force, that is the best example. We want to take here anti-parallel means in opposite direction. Anti-parallel means opposite direction. Its magnitude may be or may not be equal. Okay, 10 newtons we need to take. Those are in opposite way. Okay, those lines are anti-parallel. Anti-parallel means opposite direction. What is the angle between them? That is called as a 180 degrees. Those vectors must be 180 degrees. That's a vector is called as an anti-parallel vector. Magnitude may be or may not be equal or unequal. That's based on the given quantities. Okay, that is called as an anti-parallel vector. And next one, negative vector. Next one is negative vector. Negative vector means magnitude and same physical quantity and having a same magnitude but opposite direction. Same magnitude and but opposite direction. For example, okay, it want to take the, for example, 5 newtons force will be there in the one direction. Okay, negative vector means always in the opposite direction but same magnitude, but same magnitude but opposite direction. Same magnitude and opposite direction. If you want to take that this is the positive vector, the other vector will be in the negative. That's called as a, what is called negative vector. That's a negative vector we just take the same magnitude but opposite direction. Next one, null vector. Next one is null vector. Okay, what is the null vector? Null means zero. Zero means there is no displacement. That is called as, we can say as the some dot. Yes or no? Is there any vector? Zero bar vector. Nothing is there. Yes or no? The magnitude, there is no magnitude in the quantity. That's a, the body is said to be null vector. Okay. Are you able to understand this one? Null vector. Null means zero. Zero means there is no displacement. Okay, there is no force, no quantity will be. The quantity must be is in the zero. Zero means there is no direction also. The body, if it is moving in the some length, some magnitude is there, we can identify the whether it is the direction either positive or negative, we can say easy. Otherwise, we want to say the direction of the null vector. Okay, that's a call as a, there is no displacement. That is called as a null vector. Next one, co-initial vector. Co-initial co-initial vector. What is the co-initial vector? The name comes, it is easy to understand, no need to by heart here. Okay, co means more than one vector. Co means more than one vector. Initial means starting point or origin point. For example, if the point is there, it is a starting point or origin point. The vector will be moving like this. Okay, the vector more than one vector, it will be starts from origin point. That is called as a co-initial vector. It is a starting point. Yes, every vector will be start with the origin point. Origin means it is a starting point. It's a starting with the starting point, always co-initial. Co means more than one vector. More than one more than one more than one will be initial, starting with the initial point. That is called as a co-initial vector. That's a called as a co-initial vector. And next one coplanar vector. Next one coplanar vector. Okay, here only same. Co means more than one vector. Co means more than one vector. Planar means, for example, board is a some plane. Yes, sir. Some number of vectors will be is moving here. Okay, but one vector will be moving outside. It's moving outside from the board. It's moving outside. This vector is not a coplanar vector. It's a moving outside. Yes, sir. But those vectors will be in the same plane. Means more than one vector which is in the same plane. That is called as a coplanar vector. That's called as a we need to understand. Otherwise, if the vector, for example, A, B, C, this is the D vector, chalk piece is a D vector which will be comes outside. That is called as a it's not a coplanar vector. Yes, remaining all are coplanar vectors. The vectors which is lies on the same plane. Next one. Next one, axial vector. Okay, axial vector means a vector whose direction changes the coordinate system. Okay, the vector change its direction whenever the changes the coordinate system. For example, if you want to take the angular velocity means what? If you want to take the circular path, if the particle moving P to Q, it's making an angle theta, that is called as angular displacement. Yes, it's a moving from P to Q some displacement, that is in angularly. That's angular displacement with respect to time, that is called as angular velocity. What happen here? Whenever the vector whose direction changes, with it changes the coordinate system. Because of if we want to take the x-axis, y-axis and z-axis. In this way, we can take the circular path. What happens? The direction coordinate system also will be changes. For example, the path will be changes from x-axis to y-axis and y-axis to z-axis can be changes. That is called as a coaxial vector. Example, angular velocity and torque. Torque means it's a twisted force. Simply we can say the amount of energy is required to rotate the body is called as a torque. Next one, polar vector. Next one, polar vector. What is the polar vector? A vector whose direction changes whenever the changes the coordinate system. It's a straight line. For example, force we can say. Force will be moving in this direction or otherwise in this direction or otherwise z-axis direction. What happens? The force can be changes on x-axis in one direction, y-axis in another direction. Z-axis means it's outside. Is the changes. What happens? Force can be changes, the direction can be changes, the coordinate system also changes. That's called as a polar vector. The direction of the changes. Next one. That's a very important topic. This one is called as a unit vector. Unit vector. Unit vector means a vector whose magnitude is 1. This magnitude is 1. For example, the representation of the unit vector is, for example, A we need to take. That's a cap. Cap it. Cap indicating the unit vector. Cap indicating the unit vector whose magnitude is 1. But how can you write is equal to A cap is equal to A bar. A bar means direction with magnitude and A. A we can write in another way. How can you write modulus of A bar or A? Means modulus of A bar means it's a magnitude only. Okay, A means magnitude only. Those are in same. Okay, we can write here A bar by modulus of A bar. Whatever it may be, we can write is same. Okay, this is the formula for the unit vector. A cap. Cap indicating the unit vector whose magnitude is 1. A cap is equal to 1. But in terms of in x-axis, y-axis direction, we can be shown like this. This is the z-axis. X-axis, y-axis and z-axis. Okay, x-axis we need to take the unit vector is I cap. Unit vector is I cap. On y axis we need to take the j cap. Okay, and z axis also we need to take the k cap. Okay, x axis, y axis, and z axis. Three vectors will be indicating the. That's very important. You can keep in mind here. That's you can read and properly you can understand this one. And x axis, for example, a body is moving 2 meter distance along the x axis direction. 2 meters mean 2 into I cap. X axis. X axis means which cap is there? I cap. Or otherwise, another example. A person is walking on the y-axis 5 meters or 5 newtons means 5 into j cap. 5 into j cap indicating the direction. Okay. 5 is the magnitude, the length of the arrow. Okay. For example, another example we need to take, a person is walking on the z-axis with 3 meters. Z-axis means which cap is there? K cap. Okay. I cap indicating the on x-axis the body is moving. J cap indicating the on y-axis. K cap indicating the z-axis. Okay, this is the unit vector representations. Okay, from this unit vector we can represent the all the in this way. Next one, another vector is there that is called as a collinear vector. Another vector is the collinear vector. Okay, what is the collinear vector? Co means more than one vector. More than one vector, linear. It's a one single line. For example, the dotted line indicating the some linear line. Okay, magnitude may be or may not be equal. Okay, one vector will be moving like this. For example, a bar vector. Another vector also moving in the same way, b bar. Or we can write like this. Or otherwise, the dotted lines indicating the either equal and opposite directions also. A bar is there. For example, B bar also in the same. What is the meaning of collinear vector? A vector which is lies on the same line. Maybe or may not be magnitude equal or unequal. That's a called as a in this shown like this along the direction or opposite direction also. Which can be indicating by the collinear vector. Co means more than one vector is there. That's a linear. Same line will be placed in the two vectors. That's a called as a collinear vector. This is the types of vector. The next video will be represent as the angle between the two vectors, and next one what is the addition of the laws of vector addition of the vectors. Everything will be learning in the next video. Okay, please subscribe if you like the video. You can subscribe the video and share it. Thank you very much.